The next type of rock that we're going to study is called sedimentary rock. And we're going to break this rock study into 3 separate videos, 3 separate lessons. First, we'll take a look at how these rocks actually form, which is what this video is about. And you can see that it's this 3/4 of the first page of notes. Then in a separate video, I'll explain to you the different types of sedimentary rocks, and we'll look at some of those rock samples and find out their names. And then finally, in the third video, we'll take a look at how fossils form in sedimentary rocks, and you'll have a chance to actually make your own fossil. So let's get started with today's lesson on how sedimentary rocks form. And you don't need anything except this page of notes to follow along with this video. So sedimentary rocks are called sedimentary rocks because they come from sediment. So let's take a moment to find out what sediment actually means. Sediment is spelled S-E-D-I-M-E-N-T. And sediment is simply broken down pieces of rock. So it started as a rock and it got broken down into little pieces. And those pieces can be tiny little grains, they can be pebbles, they can be larger chunks. As long as they broke off of another rock, we can call them sediment. And you can see in my picture here that there are different types of sediment based on how large they are and also what kind of material is in them. But all you need to know is that sediment is broken down pieces of rock. So to make a sedimentary rock, the first step we need is to get some sediment. So we have to take a rock that was already formed. Let's pick an igneous rock. So we have obsidian or basalt or whatever. We have a rock that we're starting with that's already been formed and hardened. And now pieces of that are going to break off. We're going to get sediment from it. We call that process of getting sediment weathering. W-E-A-T-H-E-R-I-N-G, weathering. And obviously it's related to the word weather because it's weather that's going to cause these rocks to break down. So weathering is simply rocks being broken down into sediment. And there's a couple different ways that weathering can happen. 3 of them are related to the weather. The first one is that it can be wind. So as the wind blows along, it takes little tiny pieces of the rock and slowly over time it weathers it away. It breaks pieces off. Water can do the same thing, especially if it's a really hard pelting down rain. That will cause a lot of weathering of rocks. And then if the temperatures get cold enough, that water seeps down into little cracks, and then when it freezes and becomes ice, the water expands as ice, and so it takes up more room and it cracks the rock even farther. So all 3 of those are weather-related ways that rocks weather. Rocks are broken down into little pieces of sediment. And it doesn't have to be that the entire rock broke apart. It can just be little pieces of it that are slowly coming off over time. The last way isn't related to weather, and that is actually living things. So it can be a little creature that's digging around underground and it runs into a rock and pushes or slams against it and breaks off little pieces. It can also be plant roots. Plant roots can definitely crack rocks and push through those rocks. So that's step 1, getting sediment, weathering rocks. Now, once we have pieces of sediment, the sediment is going to have to move to a new place so that it can form a sedimentary rock. The moving of those pieces of sediment is called erosion, E-R-O-S-I-O-N. So erosion means the pieces of sediment are moved, they're transported, they're going to move to a new location. So all those little tiny pieces of broken off rock move to a new location. And it can be done by wind, or water. It can also be large chunks of ice, so like a glacier moving slowly across the land can tear up and move along pieces of sediment. And sometimes it's just plain old gravity. The rock was at the top of a hill, and so the little pebbles roll down, as you can see with this guy right here. And then once they are moving, we call that erosion. So let me just review those 2 words in a quick video. Here we have the first step of weathering. Rain is breaking down these little rocks. And then we have a living thing come along, and now that rock is eroding. It's moving along, and the little pieces of sediment are moving away. Now that brings us to step 3. Step 3 is called deposition, D-E-P-O S-I-T-I-O-N, deposition. And though we pronounce it differently when we add this I-O-N to the end of it, if you look at it, you can find the root word deposit in it. And you can also see the word position in it as well. So deposit means to move to a new location and settle down in that place. So after you're in a new spot, you stay there. You're deposited. That means you just settle down, you don't move. So deposition is where the sediment is deposited. It stops moving and it settles down in a new location. And so usually this involves a body of water, or it can sometimes involve wind, and then the wind stops blowing and it deposits it. But usually it's going to be a body of water. And as that body of water slows down, so it was a river or creek or stream that was moving really fast, and now it pours into a lake or a pond where it's more still moving water. And as it slows down, now those little pieces of sediment that were in the water now start to settle on the bottom of that body of water. Now, if we were in class, I would pass this thing around to you, but since we're not together, I'm going to have to create a video for you of it. This little tube is full of sediment, and right now it's all mixed together. So as I kind of shuffle it around, you can't see it real well. Sorry, I didn't move it close enough to the camera, but you can see little pieces of sediment, and they're all different sizes. So there's big pieces and little pieces. But now, once it gets deposited, once it gets settled down, you'll notice that those big pieces are all settled down to the bottom. So the big stuff fell down first, and then the lighter pieces are all at the top. And actually, they're still suspended in the water that way. So it actually takes about an hour and a half for it to settle down. So rather than having you watch the video and sit around for an hour and a half, I'll just fast forward to what it looks like when it's finally settled. So here is my little sediment tube. And you can see, like I said, all the big pieces. When it's moving through the water, it's all mixed together. All the sizes are just moving together. But as soon as that water slows down and deposition occurs, the bigger chunks of sediment will all land at the bottom. They'll fall out of the water first. Then the smaller pieces of sand will start to pile up on top. And then finally, the tiny little pieces of clay and mud and silt will end up at the top. Remember the way that tube looks, because when we actually look at the different types of sedimentary rocks, we'll get different types of sediment depending on what layer of rock sediment we're in. So now that it's deposited down, we have these piles of sediment. Now it's got to actually turn into rock, and it's going to take 2 steps for it to turn into rock. Step number 4 is called compaction. Compaction, C-O-M-P-A-C-T-I-O-N. And inside of that word compaction, you can see the root word of compact. Compact means pressed together, taking up less space. So if you compact something, it takes up less space. It's pressed together. And that's what's happening in compaction. The layers of sediment are being pressed together, and what's pressing them together so that they take up less space is the weight of the sediment and water that's above it. So I've got a cartoon example here, and I've got a real life picture example of what's happening. And so if you think about these very bottom layers of sediment, what's happening to them is that on top of it, there are more and more layers of sediment getting deposited, and then on top of that, there is water. So all of the weight of the sediment above it plus the water above it is pressing down on it so that the individual pieces of sediment are getting pressed together to take up less space and get closer and closer together. And then the last step is that we have to actually have the water get pressed out of it. So the water has to get squeezed out of it so that it will dry up and become an actual rock. That is called cementation. C-E-M-E-N-T-A-T-I-O-N, cementation. And again, when we add these I-O-Ns to the end of these words to get them into noun forms, we do change the way that we pronounce them. So it's pronounced cementation. But if you look in this word, you will see the root word cement in it. And you know what cement is. Cement is a man-made form of sedimentary rock. So the idea of cementation, is that we're going to get the water out of it. It will dry up. So the water dries up, or it can be squeezed out of the layers, and that's what cements it into sedimentary rock. So I'm going to show you man-made cementation. Here's a guy's patio that he made, And this is a time lapse, and you can actually see the color of the cement changing. I'll play it again for you so you can see it a little closer now that you know what to look for. You can see that the cement is changing color, and so this is the water being slowly pressed out of it, evaporating and leaving behind the dry, hardened rock. And just so you know, the longer it takes for the water to evaporate, the more tightly packed together and hardened the rock is, and the less likely it is to crack. If that water evaporates quickly, then the rock is less stable and it's more likely to crack. So that's cementation. So those are our 5 steps. Let's review this real quickly with a video. So we said the first step, of course, is weathering. This shows erosion. So we have rock particles moving along in a pond. Now we're going to look at deposition. So they're being deposited on the bottom of the lake. Now we have compaction, where we have layers pressing down on top of it. And then the last part then would be cementation. So the water is going to dry up and it leaves behind our sedimentary rock.